Thank you for joining us on this support session to do with functions and derivatives. Look, I've spelled derivatives incorrectly. Oh well, need a dictionary. Derivatives, tongue twister. So, here we go. We're about to do some maths. I'm in a good mood. I'm not sure about you, but anytime I get the opportunity to do mathematics, it keeps me awake. I don't need coffee while I'm doing mathematics. That's a good thing. Meanwhile, let's have a look at this question that we're looking at today. Now, this is a question on a past paper that refers to figure 1, shows a sketch of a curve with an equation y equals function of x. We're not told the actual equation. The curve passes through the point 0, 7, it's here, and it has a minimum point at 7, 0, which also on the x-axis there. On separate diagrams, sketch the curve with equations the function of x plus 3. So now there's two types of graphs we're asked to draw. First of all, the original function at 3. So the height will be plus 3. So really it's the original function and translated or slid up 3 units. And that's really all we have to do. So each point has to go up 3 units. So if I take 0, 7, 0 and let's do 3, 4, 5, 6, 7, that's about that height there. We're going up 3 units, so the turning point is going to be at the point 3, 0. Now this is going to go up 3 units, 1, 2, 3, up to the point 10, 0, 10. And every other point is going to move up 3, so we have to store this. And that should be drawn on a separate diagram. So I'm just using the question. So you should be able to also put 7, 3 as your minimum and put where it crosses the axis here, 0, 10, which you need to put. And this is y equals the function of x plus 3. Now, the next part B is y equals function of 2x. Now, what does this 2 do? Now, when there's a factor of x, what this effectively does, it doesn't, we're going to be saying there is a horizontal stretch of the function. Means everything stays at the same height. Let go back to the original function. I'll use the red for this one. Everything's at the same height. It's just going to be stretched from the y-axis. Now, don't look at that and think it's going to be doubling everything from the x-axis. What you've got to do is look at that that value. It's not a fraction, it's just 2. But we're going to flip that fraction and get the reciprocal of 2 over 1 because that's actually the stretch factor. It's going to be everything halves from the y-axis. So it's a stretch, but not a stretch away from the x-axis. It's like a stretch towards the x-axis. So what everything does, will halve. So instead of being at 7, 0, it's going to be at 3.5, 0. This is still going to be at 7, 0. But everything pushes together. So what was here is halfway. So we're going to get like a thinner graph. Come down. I was heading towards that point. And turn there. It can be steeper. There we have the graph. It needs to be half. That's not quite halved. So I just don't have my rubber, my eraser's not working. So effectively, it should be more, should be here. Great. Okay, there you go, beautiful. So just to, this point is 3.5, 0. This is still the point 0, 7, and it's going to come down and turn that point, and that's what they're looking for. Okay, so be careful with those stretch factors. On each diagram, show clearly the coordinates of the minimum point. Okay, there's the minimum point, 3.5 and 7, 3. I've covered it over in red. And the coordinates of the point at which the curve cuts the y-axis. So this still cuts the y-axis, 0, 7. The green function, the first one, will cut the y-axis, 0, 10. Okay, so ignoring our parts that we didn't want to show, I'd like to have my rates working. I'm not sure why it doesn't work. I've got to work that out. All right, so that's a simple question. That can actually take too long. Let's have a look at the next. Did I have a solution? Okay, here's the solutions. Just checking it. We've got the point here, the minimum point at 7.3, and returning the y at 10. And for the second graph, the minimum is 3.50, and it's crossing at 7. So we're okay. So we've got the first graph at 0, 10, and at 7.3. And the second graph, we've got it 3.5, 0, 0, 7. So the second graph is good. Let's have a look at the next question. Here we have to derivative differentiate to find f dash x. Well, f of x is 3x plus x cubed. Well, here we go. F of x, the derivative of 3x, 1 times 3, and that x drops down to 0. That's simply 3. You can just put f dash x is simply 3. 3 times 1, and then drops that power down to a 2. So 3x squared. Okay, there is f dash x. So we have to do part A. Now, given that the derivative is 15, that this value here is 15. So part B, find the value of x. If this value here is 15, so 15 equals 3 plus 3x squared. 15 minus 3 equals 3x squared. 12 equals 3x squared. Divide by 3, 4 equals x squared. Don't just put a 2. This is plus and minus the square root of 4 is x. Therefore, x is positive 2 or negative 2. So there are two solutions for where this graph has a gradient of 15. By the way, just for those who may have noticed, it is a cubic and it's 3x plus x cubed. And what they've told us is there's two places where the gradient is 15. So the gradient is 15 in two places. Here, gradient might be 15, and again here, where the gradient is 15. And so we get an x value at that point 2 something, and the x value at that point is negative 2 something. They're not asking for that. That's just a little bit extra. Let's have a look at the solution. All right. So 3 plus 3x squared, that's all we needed. 3 plus 3x squared, yeah, for the first part. And oh, hang on. Did I get it wrong? Well, look at that. You see, if I answered this on a test, I would have got it wrong. Let's have a look at the wording. And there is something I've missed. X is greater than 0. X cannot be negative. You see, at some point in time, they ignore all of the values less than 0. So if that's the y-axis, x cannot be negative. What will have happened here? And start to try and simplify, ignore plus and minus, ignore negative 2. Well, I wonder if I should lose marks or if I would lose marks. Well, I would say yes, I should lose marks, simply because I've given a value which was a negative. And it'd be disappointing if I was awarded full marks for that question, because the question did say that x is greater than 0, and I've given an answer which is not greater than 0. So I would hope that I've lost the mark for that question. But be careful. When you've given find the value of x and you've got a positive and a negative, somehow it's a good idea to just go back and don't make my mistake. Check is a negative is okay, and I should have really highlighted that at the start, and that would have avoided that. Okay, that's good practice. So it's nice to be wrong occasionally. First time for everything. Not. Yeah. Well, look, enjoy your practice. Find other questions which are similar if you can. And meanwhile, until we talk again, stay happy.